So today has not been, fuck me, yes, alright. So this week has not been a fantastic week for me getting a lot of sleep. It pretty much started Sunday night and it has rolled straight through to now. It has been less than 5 hours of sleep all week long. So it is really impossible for me to think too clearly about anything. So I think this is a perfect opportunity to make this video. From time to time, one of you guys will ask me to look into a cause that you feel strongly about. Sometimes, oftentimes, it's medically related. And I'm fine with that. You know, I'll look into it and I'll do whatever I can to talk about it. But I gotta be honest, I know a little bit about genetics. I know a little bit about chromosomes. This is beyond me. The whole idea of it is utterly beyond me. I don't like to see people suffer. I don't. But there's a point when you know, I've never been one to say that things are impossible. I've always said anything's possible. But there are a lot of things that are highly improbable. And this is one of them. This is a tall order. And I think honestly the cool thing about this is by the time we're capable of doing this sort of thing, I think that we will have evolved enough as people that we will be capable of being responsible with what this could mean. But I do know one thing that it could definitely mean, and it could mean a lot of people helped with a lot of conditions. A lot of people that are suffering wouldn't have to. A lot of people that are suffering wouldn't have to if we could figure this one out. But wow, like it's essentially like it's really interesting. But I didn't even know that this condition existed. I think it's a very interesting condition. It's interesting how it presents, the many ways that it presents. It's really interesting. The more that we learn about ourselves and what our bodies can be made up of, I don't even know. But I think this is definitely something worth researching. I think that people are going to have a lot of ethical concerns with it, but like I said, by the time we can figure this out, I think that we'll have gotten to a point where we can be responsible with it. At least I hope. But it is definitely something that I think I'd like to share with you guys. And you know, if you got extra money laying around to burn, I don't think that this is a terrible place to put it, but you know, it's a tall order. It's gonna take a lot of money to figure this one out. I don't know. This is really rough. This is a really rough one. I looked into it and I looked into it and I read some sites about it and I read some things about it and I watched some videos about it and I'm just like, I don't even know how to make this video. But I guess I'm just gonna mirror this speech from this nice doctor who is kind of heading up the research for this condition. And so, here you go.
Hi, I'm Janine Cody. I'm director of the Chromosome 18 Clinical Research Center in the Department of Pediatrics at the UT Health Science Center. And the journey that brings me here today began with the birth of my second daughter, Elizabeth. And before she was born, she was kicking so hard that I felt like I had bruises on my stomach. I was checking the mirror to look for black and blue. I was very worried about how I was going to contain this forceful child. Whether or not this baby was going to be healthy never crossed my mind until the delivery room, when instead of saying it's a girl, the OB said, get a pediatrician stat. The reason the pediatrician said this was because Elizabeth was born with a bilateral cleft palate and cleft lip and what appeared to be club feet. So her mouth was one big opening from the side of her mouth up to the top of her nose down to the other side of her mouth with a little tab of skin, and her feet turned in. This isn't a good thing, but you know, these are things that are repairable. They're not trivial, but they are repairable. And before we left the hospital, we had appointments with a variety of specialists who were going to get us on the road to repair. And when she was 6 weeks old, she seemed like a typical child. She was pooping, crying, eating, all those things that newborns do. I mean, what else do they do? And so we thought these were our only problems to deal with. And then the pediatrician called when she was 6 weeks old and asked me to come by his office. So I went in and he said, sit down. And he handed me a book and he said, she has this. What she had was a missing piece of chromosome 18, a missing piece of the long arm called 18q-. And this was what caused all of her problems. And it was very rare. There were only 60 other known cases in the world. And the book had a long list of other problems that we hadn't even thought about. It had heart defects and kidney malformations and severe intellectual disability. So here's a picture of Elizabeth's chromosomes. This is a picture taken under the microscope from the chromosomes in one cell in her blood. And you can't really make much of this. So what is literally done are these pictures are cut up and they're reorganized. So the chromosomes, they come in pairs, one from mom, one from dad, and they're organized from largest to smallest. And you can see chromosome 18 over there. At the very end of the bottom of one of those, it's a little bit shorter. So that's what 18q- is. And just for reference, someone with Down syndrome would have 3 copies of chromosome 21 down there at the bottom. So 18q- is a chromosome abnormality, as is Down syndrome. So it's in the same category of conditions. So over the next few years, I started to get used to this new life with 2 or 3 days spent at the hospital at doctor appointments, a couple of days a week doing early intervention. We had multiple surgeries. As you can see here, she looks a lot different. We were feeling like we were on the road to repair, but I kept wondering, why isn't 18q- repairable too? Now, I had been a biology major in college, so I figured that taking a chunk of chromosome and stuffing it into every single cell in the body and every cell in the brain was probably not a viable solution. But this was the 1980s, and the Human Genome Project was just being conceptualized, and we thought there were 1,200 genes on chromosome 18, and I knew that someday we would know what all of them were. But we didn't at that point, and we were just trying to figure it all out. But we also not only didn't know about the genetics, but we didn't know what was going to happen with Elizabeth. By the time she was 2, she was learning to walk. She was very opinionated and making her wishes known by pointing to things. But her growth was just terrible. When she was born, she was at the 50th percentile for length, but by the time she was 2, she was way, way below normal. So I asked the pediatrician, I told him I was concerned about her growth, and he told me they're all short. And I did not find that to be a very satisfying answer, and so insisted on some testing. And so we tested blood, and we tested urine, and we tested stool sample and sweat, what seemed like every test known to medicine, and everything came back normal. And then he finally tested her for growth hormone deficiency, and we learned that she made almost none. So luckily, growth hormone therapy had become approved as recombinant therapy in the previous year, and she got started and grew like crazy. She went from size 18 months to 4T in 1 year, and she started to really look like a healthy child. So I thought, wow, if this is making this much difference for Liz, then what about those 60 other families in the world whose kids have 18q-? Shouldn't they hear about this? And what if they've learned things I need to know that would help Liz? So I started a nonprofit parent advocacy organization called the Chromosome 18 Registry and Research Society in order to facilitate the interaction between parents, to meet other parents, find out what they'd learned, and work together to make lives better for our children. But there's only 60 people in the world with 18q-. I thought, oh, that's probably just what the book said. There's probably 100. And so it's still pretty rare. So let's include the people who have missing pieces from the other end of the chromosome, or maybe duplicated pieces of the chromosome. So if we all work together, maybe we'll have 100 families. So today, the Chromosome 18 Registry and Research Society has over 3,000 members. We have annual conferences in North America with over 300 people in attendance. We have conferences every other year in Europe and every fourth year in Australia. But we learned very early on that there were no real experts on any of these syndromes. There are a lot of people who could diagnose it, but nobody really dedicated to understanding how to help these kids. Also, we learned very early on that it was really easy to send out a survey. But then what do you do with the answers? How do you take that information and move it to the next step? So we learned that in order to have answers that were productive, that helped us really learn something, we had to ask the right questions. How do you ask the right questions? Well, you have to know about the content, you have to know about medicine, and you have to know about science. So that means you have to work with a medical center. But how do you get a research project started on a really rare condition and you don't have any money? So I enrolled in graduate school here at the Health Science Center in Cellular and Structural Biology. So here I am with my daughter Liz and my parents on graduation day. You can see she's not exactly lying in a vegetative state, and she hates this picture. My goal was to get the skills and the knowledge and a PhD so that we could develop a research center dedicated to kids with chromosome 18 abnormalities. So here's Team 18, taken a couple years ago at the Whitty Museum in the genome exhibit. And the goal of the Chromosome 18 Clinical Research Center is to make the chromosome 18 abnormalities completely treatable. I was a child of the early 60s. I hate to admit, but I was. And I saw what was an absolute fantasy idea of people going into outer space or going to the moon become an actual reality. So for me, the fact that the chromosome 18 abnormalities are not treatable is only because no one has tried. So that was our goal. We needed to try. And today, we have over 500 families enrolled in our research center. They come to San Antonio from all over the world. San Antonio and the Health Science Center is Mecca to these families. When they come here, they see endocrinologists, neurologists, neuro-otologists, psychologists, and about every other ologist you can think of. And today, we know that chromosome 18 actually only has a little more than 300 genes, but we really don't know what most of them do yet, and that's what we're trying to learn. So we're learning how to treat the symptoms, we're discovering the genetic basis of the conditions, and we're devising new approaches to treatment. And this is just one of the many exciting projects in the Department of Pediatrics here at the UT Health Science Center. Thank you.
See what I mean? That's a tough one. Altering humans on a chromosomal level. That's a tough one. I don't think it's impossible. I think it's possible. I don't know about seeing it in my lifetime. Certainly be interesting. But, hey man, if we can figure this out, we can help a lot of people with a lot of things. So, at the very least, I think any knowledge you don't have is worth getting. So, I definitely see value in the research because of research's sake. you know, and you never know what you're going to find out. They wanted to go to the moon, we all get Velcro and Tang. You know, who'd have thunk it? You never quite know what's going to get developed along the way. And that, at the very least, is a damn fine reason to toss some disposable income that direction. Just saying. I think that, yeah, I think that it's definitely a good idea. So, figured I'd share this with you guys. I'll provide links in the description for everything. And, yeah, have a good day.